In this short video, I will look at correlating data. You may have data from several sources on your graph, and correlation or enrichment of these data sources may be required. Firstly, I will show you a lookup node, which is used to enrich a data source with reference data. Then I will show you a join node, where two data sets can be joined using a key value. On my graph, I have three data sources: a transactions file, a price file, and a customer information file. This graph also contains some nodes necessary to prepare the data for use. My first task will be to enrich the transactions data with the price data. I will view the data in the transactions file. The transactions file contains the columns account ID, date, and item. I will also view the data in the prices file. The prices file contains the name of each item and its price. I will use a lookup node in this instance, as these work best when one of the data sets is small. The lookup node is found in the correlation category in the node library. Once the node has been added to the graph, I need to join my datasets to the two input pins on the lookup node. It is important that the large dataset is joined to the first pin. This pin is called the data pin. The smaller datasets should always be joined to the second or lookup pin. The two datasets need to have a matching key field in order for the lookup node to work. In this case, it is the item field. I will double-click on the lookup node to configure it. It is always useful to enter a name for your node. I will right-click in the input key field and choose Inputs from the menu, and then I will choose Input 1. And then I choose the key field from the first input pin. Then I need to do the same for the second input pin in the lookup key box. When both key fields are filled in, I will click OK. Then I need to run the node. The output from the lookup node will show all the records from the transactions file, with a corresponding price from the prices file. Next, I will join the customer and transaction files using a join node. In the correlation category of the library, there are three main types of join node: inner, left, and right. For this example, I will choose a join inner node. This node only joins records where there is a corresponding record in both of the input files. All of the join nodes are configured in a similar way. As for the lookup node, there must be a corresponding key field in both input files. In this example, it is the account ID. I will join the transactions data to the top or left pin, and the customer data to the bottom or right pin. I will double-click on the node to open the node editor. For the join node to be run successfully, the data from both files needs to be sorted by the key fields. If this has not already been done earlier on your graph, set the sort left input and sort right input radio buttons to true. Then enter the name of the key field from the first input pin into the left input key field. Remember, you can right-click and choose the field from the Inputs menu. If the key field from the second file has the same name as the key field from the first file, you do not need to change the text in the right input key box. The text that you can see here is a parameter. This particular parameter copies the text from the left input key into the right input key. Next, I will click OK. Then I will run the node. The output from the node contains the joined dataset. It contains all the fields, but only those records that have a matching account ID. The final node I am going to look at is the Xref node. This is a special join node that performs 3 joins: the left, inner, and right. It has 3 output pins, 1 for each type of join. This join is also found in the correlation category. I will join this node to the enriched transaction data and the customer data. The node configuration is very similar to the other join nodes we have seen. Again, the inputs need to be sorted. And the key field needs adding to the left input key box. Just like the other join nodes, if the key fields from both inputs have the same name, you can leave the parameter in the right input key. Once the node has been run, the top output pin shows the left join, that is, records that appear in the first dataset but do not have a match in the second. The middle pin contains records that have a match in both datasets, just like the inner join I used earlier. The last pin shows the right join, records that appear in the second dataset that do not have a match in the first. For further information about lookup and join nodes, please refer to the Correlating Data white paper.